universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all seems with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hello and welcome everybody to SkyTour Livestream. It is I, Mark D'Antonio. And as always, I am joined by the ever-present, ever-astronomical Darrell Mason. Hey Darrell, how are you?
Hello, Mark. I'm good, thanks. How are you? Hello, everybody. Howdy.
Howdy, howdy. Yeah, I'm doing good. This beautiful double star, I've talked about it many times. It's a visual double. We see this beautiful orange K star here, and we see this beautiful B star right here. These two stars are just a stunning pair in the night sky, and this is called Albireo, by the way. And if we can quickly go to our planetarium shot here, I want to show you exactly where we're looking. This is Cygnus the Swan, all right? And Cygnus the Swan, of course, as we see, Albireo is like the eye of the swan. If we zoom in, and Deneb is at the other end, and that's the tail Deneb means tail, I guess. Darrell knows more about those things than I do.
Means tail.
Hey, how about that? But if we zoom in on the swan, you can see this beautiful star, and I'll shut this off. Albireo is a neat double star. This red square, by the way, is our size of our field. It's 1.5 degrees wide by 1 degree tall. So it's actually kind of cool. It gives us a nice sized wide field. A little smaller sized field than the previous camera. And this camera, as I've mentioned many times, is better tuned to the sky. We actually show more stars than Stellarium does, than this planetarium does. So here is Albireo, the beautiful star pair. And as I said, it's a really, really very enjoyable, very exciting pair. Now, I started this a while ago when I first opened up the observatory. So if you look right here, you can see that I've got 240 exposures I've done so far of Albireo. But I've just been letting it go. And I did my focusing and everything on it, take care of all the housekeeping. And tonight, as usual, we do have a gibbous moon, a waxing gibbous moon. So we're looking at a very interesting evening because the moon does add brightness to our view. But as you can see here, we are actually able to avoid a lot of that brightness because I've got the special filter we're using, which can knock out a lot of the moon glow. Not all of it, but a lot of it. I do want to say hello to everyone that's here and just welcome them. There have been a lot of people that have jumped in already. We've got Michael Hedrick with us, Daisy and Zoe's with us, Donald Kunzer's here, and hey there, hey you guys. And of course, Cosmic Ray is with us. How are you all doing? I hope that everything is going well. Tiffany Echo is here with us. Tiffany is the one half of the powerhouse couple that are giving us all the equipment that we give away, and it's wonderful. Last time we had 2 winners. We gave away 2 pairs of binoculars courtesy of Calibos or Michael Tarr and Tiffany, and we have 2 very happy people. One of them is named Janie, and she lives in California, and the other is Keith. And Keith and Janie are going to have a great time with these Celestron Cometron binoculars, courtesy of SkyTour Livestream and Tiffany and Mike. So I think that's a really, really good thing, and I'm glad that they enjoyed that, or will enjoy that once they get them. So that said, we have way too many shots here. So, but I'll let you see this beautiful pair. I'm just going to zoom in on it a little more so you can see.
Looks good to me.
Look at those colors.
As long as the color doesn't saturate.
Yeah. Now, one thing we can do is we have a trick that I use. I'm going to take our brightness curve and drag it over down to the far right to make the colors even more obvious, as you can see. Now, it will apparently lose some of the stars, but that's okay, because what we're doing is we're actually highlighting this beautiful pair of stars. There we go. Look at that. Beautiful, huh? That is so pretty. I'm going to save it like that too. Save exactly as seen, because the raw file is not going to be affected by this. We're just taking the top surface and manipulating that, but the raw file takes all of the layers and presents them to you. So this is a pink file, so if you download just this, then this is what you get. This is the actual image you get. So you'll be able to zoom in on that and check out Albireo, these beautiful K star and B star.
Colors are a nice match too.
They are indeed. The K stars are an orangey star, and this is certainly orange. And the B star, the B8, is a late type B star, and they tend to be blue. So that's beautiful. Okay. So now we are up in Cygnus the Swan. So we're going to start riding up the center of Cygnus and enjoy some of the sights in there. Some of the things we haven't done before. I want to say hi to the Goblin who just joined us, and Starland. Hey, Starland, and DK80018. Nice to see you. Thank you for dropping by. The Goblin, one of our past equipment winners, has joined us. That's nice. I forgot to mention that just a moment ago. And then, of course, we have Red Angel. What's going on, man? Nice to see you. So, this beautiful double star, we did a calculation, knowing how far away this pair of stars are and how far they're apparently separated in the sky. We can calculate their actual separation from each other in reality. And these, if I recall, when I did the calculation, it worked out somewhere just around 5,000 astronomical units. These stars are apart from each other, if individual size. Now, in terms of how far away each star component is, well, if we take that into account, the numbers change radically, right? Because these are not apparently an actual double star where they're revolving around each other. They're a visual double where one star is up here, one star is way, way back here, but they tend to look like they're next to each other in the sky, but they're not. They're actually separated by quite a lot of three-dimensional distance. But for real doubles, we can do this as well. It's really cool.
5,000 AUs isn't all that far in the big picture.
Yeah, I know. But in terms of their separation, if they were actual double stars separated by this amount, and if they were at the full elongation of their orbits, then 5,000 astronomical units would be a fairly accurate assessment of how far apart they are. But they could be here or in a slightly different position. Yeah. So that's just a rough estimate. It works only if you know where they are in their orbits. You can get the actual value. I use that calculation to determine like the size of nebulae in space, because you can get that pretty accurately. Okay, so there's Albireo. It's beautiful. All right, so we'll come out of Albireo now and go back to our low light mode. And low light, of course, is going to be higher light because we have the moon in there. And this is what we see. All right. So, yeah.
Waxing gibbous moon.
That's right. Wax on, wax off. Waxing gibbous is what we got.
And you could take the pebbles from my hand.
That's right. Now, we won't be able to show you tonight, but Jupiter and Mars are quite close to each other, and they just passed their closest approach the other night. And I know Darrell had something he wanted to mention about it. So if I might, I will bring up his diagram, which I just did. And in the screen, you see this image from the online version of Stellarium. And Darrell will tell you about his experience in checking this out. So
okay.
So go right ahead,
well,
Darrell.
It's been cloudy here. We're in the summer monsoon. It's been interfering with Mark sometimes too. Tuesday night, I guess it was cloudy when I went to bed. But when I went to bed, I told myself to wake up at 4:30, and amazingly enough, I did. Didn't even need the alarm clock. I got up and got dressed real quick and went outside, and it was there. There it is. Okay, and this is what I saw. This was my sky at 4:30 a.m. on August the 14th, yesterday morning. I have mentioned a time or two, I think, that this Jupiter-Mars conjunction was coming up on the 14th, and they were closest that morning, right about 4:30. You can't see Mars in this image, and this is a screenshot, so we can't manipulate it. It's not live. But Mars was sitting at right about 11 o'clock to Jupiter, and less than, it was about a half a lunar diameter apart. They appeared quite close in the sky. They looked even closer than that. If you see Taurus there, well, the V shape is the Hyades, with Aldebaran being the eye of the bull, and the Pleiades were just above. But then from the Hyades, the V, if you see those two legs extending out to the lower left, those are the horns of the bull. Okay.
I messed up, Darrell. Hold on a second. I did the wrong thing.
It was just a beautiful sky that morning. It had cleared wonderfully, and I could see
There we go.
Ursa Major and Gemini were behind a tree, but everything else in that image I could see, and it was gorgeous. This was the grandest thing I've seen in years, maybe since the solar eclipse in 2017 even. I'm not sure of that, but this was really a knockout view. And Auriga was just to the left. That's Charioteer, as we've mentioned. The Capella is the goat star. And the three little stars just to the right are called the kids, the baby goats he's holding in his arm. Gemini is just under. Orion was beautiful, just under Taurus. And then trailing off to the right is the river, Eridanus. And Cetus, which is the whale. It was the sea monster that Perseus showed the Gorgon's head to turn it to stone and save his girlfriend Andromeda, which is up toward the top there. And Cassiopeia, Andromeda's mom, is just to the left. She's the queen. Cepheus is the king, her parents. And then there's Andromeda and Perseus. But this is what I saw Wednesday morning, and it was just absolutely gorgeous. To top things off, there were several Perseids while I was out, and a really good one came right out from the radiant point there next to the tip of Perseus's head at the upper left of Perseus, and it shot down toward the south right across Cetus, and it was a big gold-colored meteor with a green tail due to oxygen, and it was beautiful, just like that. It was really long too. All in all, it was just a great naked eye view. Who says you need a telescope every time, you know?
True enough.
It was just absolutely gorgeous to see. And since we couldn't share it live, I thought I'd share that with you here very quick, Mark. Thank you for indulging me.
Well, thank you very much, Darrell. That was wonderful. Really, really nice.
Yeah.
I'm quite certain that this is a view that will persist, for a few more days anyway, while Mars is where it is.
Yeah. After the 14th, Mars started moving away. It was a little bit farther to the left this morning, and it'll continue moving away. There's an interesting thing going on. Mark, if you can put that back up for a second.
I can't. I got rid of it.
Okay, never mind. Well, if you see Albireo here, and imagine the little one is Mars and it was red, and the big one is Jupiter and it was bright white, pretend they're Mars and Jupiter. Now, Jupiter being the king of the planets, he spends a year in each sign of the zodiac, those zodiacal constellations along the ecliptic plane. Last year he was to the west in Aries. This year, Mars is hanging out in Taurus the Bull. Jupiter is, that is. Now, Mars is different. Mars is the next planet outside our orbit, and Mars tends to scoot along through the sky ahead of us until we catch up to it at opposition, which, if I remember right, is early next year. So this was fortuitous this night. Mars came in from the right, got closer and closer, and then passed on the morning of the 14th. And now he's continuing to move off to the left or the lower left, headed toward Gemini. Jupiter will be at opposition, next month, or Saturn next month, and then Jupiter after that. So Saturn is near opposition now, actually, getting there, and Jupiter will be there sometime after, and then Mars early next year. They'll all be in opposition.
Saturn's rings are actually starting to become more edge-on, and I think that'll be coming up soon. In the coming year, I believe they're going to be
I think next year they'll be at their closest, in which time they'll disappear.
Yeah, it'll look like a yellow planet. Only
Yeah.
only spaceborne telescopes would probably be able to easily see the line of the rings.
Mm-hmm.
All right, cool, guys. That's fantastic. Thank you, Darrell. That was actually pretty cool.
Thanks for indulging me.
Sure. Let's see now. Since we're up in Cygnus, why don't we take a ride a little bit further north, up in here, and there's one that I wanted to look at, and I will still see it even with the moon. Beyond waxing gibbous, the moon is a little bit trickier to kick out with its light. It's going to be kind of hard. But I want to go to this guy right here. Alright, this is a beautiful nebula. And we'll check this out. So we're riding up now. We're going down the neck of the swan. You'll see the telescope moving a little bit away from us now as it does that. It's hard to see it do it, but that's what it's doing. And as it moves away from the neck of the swan, we're moving in to a region where we have a nebula that we want to check out. And what I'm going to do first is just scroll this out a little bit here. Alright. Now, let's find out if we are on target. Sometimes we're not on target, and that's okay. First thing I'll do is I'll go to this guy, Eta Cygni. And Eta Cygni, once we have Eta Cygni in there, centered up, there it is, then we'll know where we have to go. So what I'll do is I'll bring up our targeting reticle, and I will move this view and make sure that we've got our coordinates locked on. There we go. We just have to get close. I hope you all are having a good time so far.
Still looking for where I posted that picture. I don't see it.
It must be in your downloads.
Actually, I don't think I saved it. I just posted a link in our chat.
Oh, okay. Okay, so there we go. So that's good in that quadrant, and what I'll do now is see how far off we are. Okay, this is Eta Cygni, which is where we are right now. And now I'll zoom in and I will synchronize so that now our telescope and our coordinate systems are locked in. There we go. Alright, so now we come back to this.
Oh, there it is. I'll post a link in chat. This is a gorgeous picture, telescopic view of Mars and Jupiter in the same view.
Okay.
And you can actually see detail on the surface of Mars and the cloud bands and the moons on Jupiter.
Oh, I think you sent that picture.
I did, yeah.
I saw it. And it's a really pretty one, guys, so check it out later. Okay, let me...
And if you click on the pic, you can make it bigger.
Yep.
There you go. That's the picture. It's you don't have to put up with Reddit. That's just an image. Izabela's here. Hi, Izabela.
Hello, Izabela. Alright, let's check out this nebula here. Let's give it a 25-second attempt. We are guiding, and I'm going to go into deep sky mode from low light mode. There is the Albireo, the previous image we shot. Beautiful, beautiful, beautiful. That's up on the server. And now we'll clear this and bring in the next thing. So tonight we're riding up Cygnus. So we're going to go from the eye of Cygnus Albireo, partially up to this next object here. This is called the Tulip Nebula. I'll change the name here in our identifying box, Tulip Nebula. I can also do it by doing this, by having it solve for this directly, and that's interesting. Isn't that interesting how this doesn't know the Tulip Nebula? That's okay.
Maybe you need to designate a catalog.
No, this is not like Stellarium.
Oh.
See, I've got like for settings, look at I got everything selected. And yeah, well, that's okay, so that's interesting, but that's what happens sometimes. It doesn't always capture. All right, let's go to our histogram now. And what I'll do first is I will color correct, because you see our red, green, and blue curves are off. They need to be aligned under each other. So by doing this, you'll see them line up, and we get a more color correct version. You can see the beautiful reds, diffuse reds back there. And we have our mid view, our mid range value here. Our mid level value is way down. So I want to bring that up. So I will give it the parameters. I'm going to tell it to do the image processing it thinks it needs. And now we see in reality what's really there. Now we're seeing some real stuff.
I thought the tulip was blue.
No.
Maybe I'm thinking of the iris.
You are.
Yes. Sorry.
The iris is a reflection nebula. So we'll take our dark component and ride up the curve. And as you can see, that adds maximum contrast. Look at this beautiful region. Right? Look at that. You'll see inside this nebula, the Tulip Nebula, we've got these beautiful spires of black dust. They happen to be overlaying from this region. This is all dark dust that's overlaying into here. All right. Let me color correct that to get the color better.
There's a little loop or something just to the left of that bright star over on the right edge, the very right edge. Is that real, or is that...
Or are you talking at the right edge here?
Yeah, right there. Just to the left.
Oh, this?
You see, sorry, I was confusing my pointer with your pointer. If you see the bright star...
Yes.
Go out even with the edge of the...
oh, right there.
Yeah, you see that? Is that real?
Yeah, that's real.
Looks like a loop of stars.
Yeah, I'm going to zoom into that just temporarily here. That little loop of stars that Darrell's talking about appears to be a very real... well, these could be just stars that happen to be in the region. Let me enhance this even more. Ready? Watch this now. Boom. Make it even look better. Look at that. Yeah.
Look prettier with the colors.
They are. That's beautiful. Okay.
Alrighty.
Yeah, that's really nice. And the more that we expose here and lay on values, you know, remember, this is an image sandwich. We're taking one image and then we align it with the one that was just taken and then stack them on top of each other, make an image sandwich. The thicker the sandwich, the less noise we get. So as...
Like a cosmic Dagwood.
Like a cosmic what?
Dagwood. Don't you remember Dagwood?
From Bewitched?
No, Dagwood and Blondie.
Oh.
The comic strip.
Yeah, I remember that.
Yeah, he made the famous Dagwood sandwiches that were 3 feet tall.
That's right. All right.
God, I'm old.
I just didn't remember. I'll color correct again. We got a little touch of green in there.
I'm still old.
Ooh, and look at that. We got a satellite go zipping through for one of these frames. So you see now, if we zoom in a little bit on this nebula, you'll see that in here you got this dark nebula, and it seems to be reaching in and going in front of this nebula behind it, and that's exactly what's going on. The universe is in 3D, guys, and it's beautiful. And by the way, we're working on original music for SkyTour livestream as well. This music comes from YouTube's archive, and we're going to be using our own music that we created. I've got like 10 cuts so far. I previewed a couple with you guys online. There you have words in them and stuff like that, but we can do instrumentals. Izabela's, of course, a whole hog on this too. She really enjoys doing that as well. So we're gonna be hopefully doing that soon. I have to color correct here. Look at the reds. This is really pretty. Yeah. Look at that. Ah, that's beautiful. Let's zoom out and see the whole extent, shall we? Talk about a universe, guys. Look at this.
Well, this was one of those nights. I see lines and curves of stars over there to the left of the nebula, too.
Yeah, and within a nebula right here, we got some. There's a curve.
Oh, they're in the next red cloud to the right.
Here?
About
That's
to the left. I'm sorry, to the left.
Oh, the other right. Okay. It's over
Right
here.
there. Yeah, you see it's like a double line of stars.
Right here.
And it continues over
Look at that.
to the left.
And one goes all the way up there, too.
Yep.
So
Sometimes they almost look like they're real, like the one you pointed out is at the upper right.
like that one right there.
It looks like almost like it's along the edge of the red cloud there.
Yeah.
I wonder if those might be real.
Well, it's possible that shock waves could have initiated some star formation along the way in here at some point. It's possible. Boy, look at that. That's really pretty. Let's see if we can add a little more sharpness to these. Okay, that pulls out the sharpness a little bit more.
Michael has a question when you have a moment.
Okay.
Michael H.
Yep. What's he asking?
It'd look just the same on Mercury. You wouldn't be able to see it at all on Venus. It would probably look much the same on Mars. On Jupiter, you wouldn't see anything, nor unless you were outside the atmosphere. Ditto for Saturn, Uranus, and Neptune, and Pluto would probably look pretty much like what we see here.
Oh, I see what you mean.
Yeah, he's talking color differences.
Well, it depends where you are on the planet. In Jupiter, you've got cloud bands, and you've got these these belts. You've got belts and bands, and the belts, I believe, they sink, and the bands are up above. So if you're above a belt, then you could see out of the atmosphere. If you're in a band and the band goes up high, you have to be outside the atmosphere fully to see outward. But you might see some things. On Titan, for instance, you've got that thick nitrogen atmosphere on Titan, and it's got all kinds of additional molecules in the atmosphere, so you can't see any stars on Titan. You can barely see the sun. The sun is a dull, bright spot in the sky all day long, and all throughout its existence so far. And then on Pluto, you actually do have an atmosphere. It's very thin, and it's a water vapor atmosphere, believe it or not. And so the atmosphere during the day, you have a faint blue to the sky, very, very faint, tenuous at best. So you would be able to see the stars even in the daytime. You block out the sun, you'll still see stars, but you'll see a brighter blue toward the sun when you're looking toward the sun than when you're not. So you would see these. You would see that. Now, as far as on its moon, Charon, the primary moon, you've got Nix and these other, and Styx, you got these other moons of Pluto, I believe, and they are all airless, so you could see the full extent of the universe on all of those. So they're another. Sorry to take a drink. Those are another location where you would see some really cool night skies. We're seeing this through a big thick atmosphere here on Earth. Up in the universe, if we leave Earth and go up in the outer reaches of the atmosphere or into low Earth orbit, this would be twice as good as we see it here. But we'd be moving very fast in orbit, so we'd have to have a telescope that can focus on it. And yes, because it's so far away, it wouldn't move much. We wouldn't see any disturbance to our image at all. We could take a photo for hours and hours, and days even, and it wouldn't affect anything. The same can't be said for the planets. We would have to take shorter exposures of the planets because they would move relative to the background of their stars, depending on how long we take the exposure.
Izabela asks an interesting follow-on question. When they terraform Mars to have oxygen, will Mars have a blue sky like us too? And I want to add on to that. Sometimes the sky looks blue in like Perseverance images. Is that true, or is that just doctored to look good?
No, actually, that's true. And the thing that's interesting is it's the opposite of what happens here on the Earth. On the Earth at sunset, we see red around the sun because it's scattering the blue molecules. Well, on Mars, it's not oxygen and nitrogen doing the scattering. It's actually carbon dioxide. So what we get is we get a blue glow around the sun at sunset or at sunrise on Mars. It's exactly the opposite of the way we think. Now, we would have to have a nitrogen atmosphere on Mars to get the blue sky like we have here, all right? Because it's nitrogen and oxygen, nitrogen the larger percentage. So if they were in equal percentages, yes, we could get a purple sky. I mean a blue sky, but we could engineer a different color sky just by the molecules we put in the sky and how they scatter light. That's kind of cool. So I think that's a really neat question because it points out how we're so used to seeing the blue sky on Earth. And we know we have a blue sky on Pluto due to the water vapor in the atmosphere. We have a lot of water vapor here too. But until we can terraform Mars to get that, we can still expect the sky on Mars to, even when it's breathable, it may not be blue. It might have a hint of blue, but it's still going to be a salmon color because that salmon color that we see in the Martian atmosphere is actually due to the dust that's constantly up in the Martian stratosphere, so to speak. So that salmon color will always be present on Mars. All right.
I wonder about Pluto. I mean, I know it has a very, very tenuous atmosphere, but it's about as thin as it could be and still be considered an atmosphere.
Yeah.
You think I would still have enough body to show color?
Yeah, because we can see it, and we saw it with the backlight from the New Horizons spacecraft as it passed it. We saw the atmosphere, and we saw the haze it created, and it was a blue color. So we're able to see that Pluto already had an atmosphere that was tenuous, yes, but we could also see that it had the color to it. On the other hand, there's other possibilities, right, for atmospheric coloration, and that has to do with, again, as I said, what the composition of the atmosphere is.
Interesting.
Yeah. So this is beautiful. This is looking really pretty. Look at that. So
one could use one's imagination and think of what planet, if it had life, might evolve critters with infrared eyes. They would certainly see something different.
That's right. That's right. I mean, we have critters that only have ultraviolet eyes, only have a taste for ultraviolet. Bees and butterflies. They evolved a strong ultraviolet sense, and if you think about it, think of that symbiosis between butterflies and plants and bees and nectar in plants. Why did plants develop stems to allow creatures like hummingbirds to stick their tongues far down into the plant and get at material, fertilizing the plant and taking fertilization materials to the next plant? Why did plants develop ultraviolet signatures in their petals for insects? How did all that happen and at what point? Now, insects arrived before flowering plants. So it seems that the flowering plant's response to developing these ultraviolet targets were the result of, again, mutations followed by adaptation, which is what evolution is. So it turned out that perhaps there was a set of plants. They happened to suffer a mutation which caused them to really be visible in the ultraviolet. But at the same time, insects suffered a similar mutation at some point along the way to be able to see ultraviolet. And it had to do with how their eyes were changed, probably by interaction with sunlight over time, over many hundreds of thousands or millions of years, that they were starting to form their final patterns genetically, and they ended up being very sensitive to ultraviolet, and so a symbiosis was born. And then the flowers, probably in response to the way the bees' behavior was occurring with them, developed mechanisms to, in some cases, keep bees out. In other cases, allow butterflies in but keep bees out. It really is very complex. And we look at it now and say, this is what it is now. But how did it get there? See, that's the interesting part.
You should, well, that reminds me of, oh God, I just said Stephen Jay Gould.
Oh, yeah, I knew
He
Stephen
did
Jay
some-
Gould.
Did you? He did some great books on evolution and
Yes, he did.
the Flamingo Smile and others.
Well, some of this
how
comes
things kinda-
from him.
How things kind of co-evolve.
Yeah. I met him in Boston years ago. I think he's passed on now.
He did. He
Yeah.
passed away a few years ago.
But, yeah, he was actually quite a smart guy.
Yeah. Great bunch of books. I've read them all.
Yeah.
He was into baseball too.
Okay, yeah, we never talked about that, actually. But I did consider him a brilliant philosopher, actually.
Yeah. Speaking of seeing ultraviolet, they used to say that people who had cataract surgery implants
Huh?
could see a little bit into the ultraviolet. I don't think they say that anymore, but
Well, one of the things
they
could
used
be,
to.
I think one of the things could be that the blue color response was muted with cataracts, and so when they got them repaired,
Absolutely.
blues were so much more brilliant.
Yes.
That-
I had
You did.
cataract surgery years ago,
Yeah.
and when I got home, I mean, I couldn't see. I laid down and took a nap, and I had sky blue sheets on my bed.
Mm-hmm.
And when I woke up and took the bandage off, it had corrected well enough that I could see already. And it's like those sheets were glowing blue fire. The difference was so amazing.
Yeah. I think after a while that leveled out, right? It changed.
It did, yeah.
Yeah.
It looks like, sky blue sheets now.
Yeah.
But it was so vibrant at
Mhm.
first, and it was amazing to see the difference.
Yeah. Well, guys, this is the Tulip Nebula, and we've got we've taken 44 shots. I'll go to 45 here. There it is. So we'll save it there, and we'll move to the next. Let's save exactly as seen, and that's beautiful. I'm going to do one more thing before I finish this out. I'm going to actually color correct one more time, and I'm going to take us just a little over the hump. I just want to grab a little more contrast here. There we go. And I'll save that exactly as seen. Now the subtle blue you see in the center, that's actually from the moon interfering with our image. So if we set these to where it wants to be, this is what we get. Right? And I do not like that. Want to say hello to Louis TA, who's with us. Hi, Louis. I think I said hello to Izabela already, but she's always welcome here. And I might have missed a couple of people that came in that I did not acknowledge. Maybe not. If I didn't acknowledge you, let me know, and I shall do so. All right. So this is cool. So this is the Tulip Nebula. We're riding partially up the neck of Cygnus the Swan. And now we'll go back to our low light mode right here. And then this will be a jumping off point to go into this mode. And now we'll find our way further up. So let me bring us out. Let's actually go to not here. I want to go to here, and we'll go and fit the width. There we are. All right, and our focus still seems good. So we back out of this, and the next thing we want to do is come up here, and I think we'll do a short stint on this Crescent, which we did last time. We're riding up from Albireo. All right.
Mike Brian Bruce has a question about Planet 9.
Hello, Brian. How are you? Thank you for joining us tonight.
Says, have they seen it yet? No, they haven't. It's still supposition. Some people say there's evidence for it, how it's disturbing the orbits of certain dwarf planets farther out past Pluto.
Mm-hmm.
They have nothing definitive yet, though.
Thank you for answering that.
They used to call it Planet 10 or Planet X, but once they demoted Pluto
wrongly.
Planet 9 now.
Yes.
Planet X is for crazies. Planet 9 is for scientists.
Yeah. Well, to be honest, I'm an astronomer, and I say that Pluto is a planet.
Me too.
Here's the thing, I've said this story before. Pluto was found by a guy named Clyde Tombaugh, and he wasn't an astronomer, so he was actually, and Darrell knows this, he's talked about it, he was just sort of working at the observatory, kind of sort of an amateur, but he actually ended up comparing plates, and he actually used something called a blink comparator, where he flashes images of the same sky, area of sky with a newer image, and by rapidly going back and forth you can see differences, and he found Pluto that way. And I was sitting with him on a grassy hill up in Vermont. He was a little wiry old guy, the nicest man, and I asked him about Pluto, and I said, I know you've heard this a million times, Clyde. I said, but when you discovered Pluto, what did you think? And he had a small voice too, and he said, it was actually so exciting. I couldn't believe that we actually found another planet in our solar system. It was incredible. Had Clyde been alive to see the ruination of Pluto as a planet, I have a feeling he would not be too excited.
I have my favorite cartoon about that with some famous wannabe Carl Sagan type in the planet Pluto. And you'll never show it because there's obscene gestures going on in the picture. He said, Pluto is not a planet. And then Pluto gives him a reply back. And
that reply is not too...
no, not polite.
Well, you can't blame Pluto, right? I mean, come on.
Yeah. Clyde Tombaugh got his start. He was a farm boy out in Kansas, if I remember correctly. And he built himself a decent reflecting telescope and started studying stuff and making drawings. And he sent them to Lowell Observatory. And I forget if it was old man Lowell himself or somebody at the observatory was so impressed they hired him.
Yeah.
That's how he got his start.
Yep. I remember that. Yeah, see, that was at a time when amateurs could actually break into the business because astronomy was actually a young science back then, and it still has room for people that are pure amateurs. In fact, I mean, listen, look at David Levy, okay, or Levi, however you pronounce it. Okay, David Levy is a comet hunter. He's an amateur. He's not a professional astronomer, but he's found more comets than most people on the planet. You know, I talked to David. Last year we talked because we were gonna go see him at one of the observation locations. He was gonna go observing at a telescope, and I was gonna go. I went. He couldn't show up because he had a family commitment at the time. So we went, and I talked to David on the phone. Nicest guy, you know, but he's very unassuming, and he's very happy to listen to anyone and to talk to people. And I think that's pretty cool, you know, about people in astronomy. You know, they typically, I should say, don't get these big heads and think that they're somebody, you know?
Yeah. He worked with Eugene and Carolyn Shoemaker when they discovered Shoemaker-Levy 9, the big comet that hit Jupiter back in the 90s.
Yeah, it was broken apart by Jupiter's gravity, and yeah.
Now, Levy uses a 14-inch Newtonian reflector telescope, if I remember correctly.
And he kind of knows where to look.
That helps.
Yeah.
A real dedicated comet hunters, they have, I guess you could call them search programs. They check certain areas of the sky, like on every clear night basis. And they literally know the sky like the back of their hand. And they see something different. Well, they start taking notes and positions, and if it looks like a comet, they send it into the what's the place? Harvard? I forget what it's called now.
You're talking about the reporting
astronomical? Yeah, the reporting place.
Yeah,
astronomical telegrams or something like that. And they start documenting their findings.
Yeah. So this object here, this is one we did the last time, but again, it's on our journey through Cygnus, the swan. This is called the Crescent Nebula, and the Crescent Nebula is, as you see, a crescent-shaped nebula, but it's actually shaped like this for a reason, and that reason is it's shaped like this because of that star that we see right here, that star right there. That star is a star known as a Wolf-Rayet star. Now, Wolf-Rayet stars can be a variety of types, like I mentioned last time. They could be a Wolf-Rayet carbon-based, nitrogen, or oxygen, so WC, WN, or WO. Not sure what this type is. It may be a WC, but what happens with these stars is they're very energetic stellar winds, very, very energetic. Like you feel stellar wind from the sun. You feel the radiation striking your face. That's the radiation pressure that you're feeling on your face from the sun. And the stellar wind is charged particles from the sun that leave the sun at many thousands of miles an hour and get here in a couple of days from the sun, streak through our magnetic sheath that surrounds us and protects us, and spiral over our poles, north and south, to make auroras by interacting with molecules in the upper atmosphere. Well, these stars, the Wolf-Rayet stars, have such powerful stellar winds like that the winds alone would shear your face off. Okay, these stars have these fierce winds that are so powerful, in fact, that the outer atmosphere of the star, okay, you have a core of a star, and then you have this outer envelope of this material that doesn't get fused, just is built with the star, and it forms plasma, and most importantly provides mass to keep mass on the core, to keep pressure and temperature up. Now, as soon as the star starts to run out of things to fuse, it'll start to shrink in that core, and that'll make the star expand, because now as it shrinks, it gets really, really hot and starts forcing out energy really, really strongly for a period of time, and that'll turn any star into a big red giant. But a Wolf-Rayet star does something different. When a Wolf-Rayet star is born, its life is spent being a fierce progenitor of these stellar winds, and it will typically take that outer envelope and literally push it away from the star, leaving only the core, which is what we're seeing right there. That's the core of the star, and this is what used to be in that star's outer envelope. Now, it's not a perfect sphere, because it gets shoved off in all directions, right? It's not a perfect sphere, but we see it's sort of an ellipse, because it does go around here. Okay, and
some of that can be a reflection of the shock front as it encounters matter out in space, I guess you'd say.
Yeah, that's what I was going to mention. Exactly right. That when this material is pushed out into space, it's not going to just freely move outward. It's going to encounter something, and that something is going to be stuff like other material out there, other dust, and so forth. And that is really interesting, because this material can slow that stuff down. As it slows that stuff down that's moving outward, it can do a couple of things. It'll raise its temperature tremendously. We can see in some of these nebulae the temperatures have been raised millions of degrees, and that means that hydrogen atoms will ionize, oxygen atoms will ionize, and the ionization process is a give and take. The electrons bounce off the atom when they're ionized, and then they trickle back into the atom, and when they trickle back into the atom, they give off light. The hydrogen atoms give off red, oxygen atoms give off a blue, right, and a bluish green. And so when this happens, we see that the nebula gets ionized along the front. What could also be happening is the Wolf-Rayet star, if this nebula remains close, the Wolf-Rayet star's own ultraviolet, high-frequency, powerful energy could be ionizing this gas that it's pushed away from the star. But this distance corresponds to several light years right here. That's several light years, right? And ionization can occur several light years away from the star if it's a powerful enough star. And the Wolf-Rayet stars, well, they're very unpredictable, and they're among the more powerful stellar radiators out there in the universe. Yeah. This star is heading for supernova too, by the way. So it makes a nebula, exposing its core, and this core is eventually going to go supernova.
As what Mark was saying about how far out material can be and still be ionized by its host star. Different classes of objects have a certain kind of, they're of a certain size, like white dwarfs and planetary nebulas. That white dwarf is giving off enough energy to make planetary nebula grow, usually to about a certain range of size. And
2 to 3 light years.
yeah, and things like Wolf-Rayet star here in the Crescent, much more powerful, so it can ionize much farther away.
Yeah. As we zoom away here, you can see these other soft red glows. These soft red glows are not due to that Wolf-Rayet star. This is an isolated object that's probably somewhere where it is to be isolated in space, because we don't see any other objects around here affected by it typically. But this object is isolated. This is a diffuse red glow because there's other stars elsewhere that are hot enough to ionize hydrogen gas, the neutral hydrogen that's floating around in the interstellar medium. And within it is this dark dust. This is all dark dust. This is not an absence of stars. This is actually a beautiful interplay between ionized hydrogen gas and dark dust. They're all mixed together. And where the hydrogen is denser, it'll look redder. Where the black dust, the brownish black dust, is still more dense, it'll look dark there. But they're all mixed together. You'll get ionization of hydrogen within here, but it might be dominated by the more dense black cloud. So that's how that works. It's very interesting.
Mark, could you excuse me a moment, please?
Of course.
Be right back.
Yeah. Okay, so there's that. That's beautiful. So let's zoom in on that one for one moment here and check it out with some detail. It almost looks surreal, guys. You know, it almost looks like it's not real. But I can promise you we're not faking it. You've been with me on this cosmic journey that we take for years now. And so we're doing nothing but expanding. It's wonderful. I'll tell you one thing. This is one location I don't want to be in. And you'll notice interesting features, like this has this weird cloud here, and they've got one here. Those are probably dark dust clouds that are being affected by the light from here. So this dust cloud is scattering some of the starlight that's coming from this Wolf-Rayet star. And this might be a direct reflection along our line of sight from this particular very bright radiation strike here. So it's a very interesting feature, almost like a reflection of the moon on the water. That could be what's going on right here. And I can zoom in on that a little more. So it's possible that this brightening right here again is due to this hitting right here. This is again going to be along a line of sight of some kind, either away or in front of the star or just directly below it. And if it's at the right angle, perhaps a brightening is being caused by the starlight here hitting it a certain way, because these dust particles could be reflecting the light and scattering it at a certain way. So the universe does the same kinds of things that we see on Earth sometimes. All right, we're going to save this just like this. And that beautiful crescent will be up for you to look at, either by going to skytourlive.org and checking out the section on how to get to really cool pictures, or by getting our application when it's ready. Louis Ta says, looks like an avocado. Okay, fair enough. All right, so that is that guy. So there is our beautiful Crescent Nebula. And we're going to now go back to our night vision mode. It's amazing how much more is visible, when you take a simple picture, because that's what it really looks like to our eye. All right. It'd be very hard for you to see this with a telescope unless it was a very large telescope, and then you'd only see a portion of it. All right, cool. Welcome back, Darrell.
Thank you.
Right. So next, moving forward, we're going to move to the star called Sadr. This star is in the center of Cygnus the Swan, and so it is basically in between the wings, which go out to each side like that. Right?
Sadr means breast,
That's right.
as in breast of a bird.
You got it. So what we're going to do now is we're going to go to Sadr. We'll see Sadr show up. You'll see the telescope move very little at this point, but it's going to get there. Here comes Sadr. Here it is, right there. All right. Hello there, Fantasy. That's right. It means chest or breast. Yeah.
Izabela asks why the second camera at the telescope doesn't work.
Oh, down here. Yeah. I tried to bring it up earlier, and it basically says, I'll show you. I'll show you what it does. When I try to add the camera, it says that it can't find it. So the camera's not found. Sometimes it works and sometimes it doesn't. But to be fair, it's an old camera that was actually the camera used to just look at the telescope before. So we are going to be replacing that. I'm testing one upstairs right now, actually. It's a Wi-Fi camera that will be accessible, and I'm putting in a new machine that's going to actually have Wi-Fi on it, but will also talk to a gigabit switch that will allow us to also go through Cat5 to get signals off the Wi-Fi machine. And so that's going to be a little dance I have to do. All right, let's do this. Let's go back here. So we're centered on Sadr now, so this is where we are. Okay, and we have a very large nebula here, okay? But what I'd like to do is to capture a portion of it. So if we look at where we are on this, okay, if we look at our numbers here, you can see that they're on an angle, right? So we have to, I want to try and figure out which way to go. What's that?
The nebula is not square, by the way. It's just they highlighted that area,
Oh, that's right.
certain square area of sky around Sadr.
Yeah, I should have mentioned that. I'm sorry. And from
Hey,
experience,
It'd be cool if there was a great big square nebula in the sky.
yeah, but then people would say it's all a hologram. All right, so we're gonna put Sadr in the upper right, like this. All right, now with Sadr in the upper right like this, that's gonna allow us to image in here, which is where the nebula is really pretty. And by the way, this is called the Gamma Cygni, which is what Sadr is. We use Greek letters to signify the brightest stars down to the least bright. So it's the Greek alphabet: alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, pi, psi, rho, sigma, tau, upsilon, phi, keep, psi, omega. And of those, you're familiar with alpha, beta, gamma, which is Gamma Cygni. So it's the third brightest star in the constellation, all right, of Cygnus. So we're going to go a little bit more, get Sadr all the way in the upper right, because we're going to look at this beautiful dark cloud in here. You can kind of see it, right? Kind of see it.
Did you know that three famous physicists a long time ago, whose names were Alpher, Alpher, Betha, 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 or Betha, whatever, and George Gamow, Gamow, wrote a joke paper once and got it published just so they could get alpha, beta, and gamma out there.
That's actually, yeah, I remember George Gamow.
Yeah, he wrote a great book, 1, 2, 3 Infinity. He was like another Carl Sagan type a long time ago.
Yep.
He's a funny guy.
Okay, so we're gonna go from here. And we'll take this to a 25-second shot. And we're searching for our guide star. It will be guiding momentarily. Takes about 14 seconds to identify. Alright, here we are. We're guiding. And I'm going to now start the process. We're on our way. So we're going to now go out of low light mode and go into deep sky mode. Oh, I'm glad you enjoyed it, Michael. He downloaded the Crescent Nebula. Okay, let's see what we got. Wow. Now, you guys have to understand something. This is the first time that this camera has been used in Cygnus. Okay, this is not a camera that we have used before to do this. This is a brand new camera that we have put in, and it's being used for the first time on Cygnus tonight. Okay, let's it's just such a bright nebula. But the fact is, unless you have a very, very powerful telescope, you're not going to see this. Alright, let's bring this in a little bit too. Look at that. Alright, let's drop this blue down a little bit.
Izabela says you're flickering. There is some light behind Mark that causes his image to flicker.
Oh,
Is it
she's
possible to
talking about
turn
that.
off?
What is that? Oh, that's just a ghost. Yeah, no, I see that. That's the clock on my wall. Let me change that. I'll change that. Thank you, Izabela. I can go to this. Is that better? I think that's gonna be better. Yeah. We'll try that. Alright.
You look almost normal now.
Oh, well, let me change that.
I still think you should grow the evil Spock beard and mustache back.
The evil Spock beard and mustache.
Sure. Makes you look more dignified.
Maybe. It depends on the audience.
And a little more sinister, too.
Yeah, that's a problem. And quite a bit older. Hey, Sean Paris, how are you? Oh, hey, thanks, man. Thank you for those wonderful kudos to us. I appreciate that very much. Astrolin is with us. That's Kyle. How you doing? Well, actually, you know what? I want to take a moment to mention that we have been named in an award with Las Cumbres Observatories, a network of observatories around the world. And I think I'd like to, for Kyle, what I want to do is I want to schedule some time to look at some of the areas that we seem to have identified where there might be some missing stars. And that would be, I think, a good use of that time, at least for us. That's very important. All right. And for that, I would probably refer you to Izabela in our audience, because she is someone that's been working with us on this, and she's actually been behind almost all of that. Actually, she was trying to find all the missing stars and so forth. She might have found some asteroids too, which I think are pretty cool. The blue is from the moonlight Hey, Mr. Django. How's it going? That's Steven Smith over in Belgium. My college roommate was from Belgium. Yeah, this blue is looking weird.
Fantasy says he's going to be camping at 12,000 feet elevation 3 weeks from tonight on Mount Whitney.
Oh, you're going to Mount Whitney. Wow. Very nice.
I've observed over 11,000.
Mm-hmm.
12,000 is even better. You get up high enough like that in the daytime, you look straight up and the sky is no longer sky blue. It starts turning dark blue.
It does. You guys are going to hate me for this, but I'm going to clear this. I'll save it once I gotta try and get rid of that blue, because that's not sure why that's as blue as it is. It should be.
I didn't think of the moonlight at first. I was wondering if this was like a flat frame problem or something where it's brighter in the middle.
Yeah, that's the problem, and so I'm actually cutting off the use of I'm even using the dark frame too, but I'm actually gonna try and save this like we have it, and then I'm going to clear it and see if we can get better results. 12,000 feet on Mount Whitney. That's going to be really cool. Yeah, we got moonlight galore tonight, huh?
Ray is asking you to repeat what your camera is.
Oh, this camera's a
ZWO.
ZWO ASI 183 MC Pro. It's the 183. Okay. The only time I was at 12,000 feet was when I was flying with the Army's Golden Knight skydiving team. I was tethered in the open door, photographing them jumping out. And I got airsick on the way down. I'm telling you, I'm no hero, I can tell you that. But
I drove to the top of Boreas Pass here in Colorado one night, southeast of Breckenridge, Colorado.
Really?
For the peak night of the Perseids, and had a heck of a view up there.
Wow.
Set up the telescope too.
It was probably a little chilly.
That was over 11,000 feet. I forget how much.
Yeah. Well, I was at 11,000 feet. I forget which pass that is, but I was driving from Phoenix to Denver, and I hit a pass that was well known. Got pictures at 11,000 something feet.
Was that when you came up the San Luis Valley?
Maybe.
Probably went over Wolf Creek Pass, or
Oh yeah, it might have been Wolf Creek.
or what's the one to the east of that?
It was 11,000 and change.
Yeah. The guy who did the song Convoy wrote a song about Wolf Creek Pass.
Yeah.
Looks like we got us a convoy.
Yeah, that was a good song. Wow. Well, this is really pretty stuff. There's no doubt about it. And this is without flat frame right now, so it looks a little better. So let's zoom out a little bit so you can see a little bit more. So the star Sadr, Gamma Cygni right there, is surrounded by all of these clouds of neutral hydrogen that are being ionized. And it might be Sadr doing some of the work, but there's also other stars that are probably inside this dark nebula, which are probably contributing to this as well. It's not only this. Oh yes, Mount Teide in the Canaries. I actually used telescopes on Teide for a number of years. Teide is great. Just, don't just don't need maintenance on a telescope. There's a telescope up there. I was using the Bradford Robotics telescope. A Bradford Robotic telescope. It's done now. They're not used anymore. But the Bradford scope, you could schedule objects to be taken, and I did. And you'd get them like the next day. But, Teide is rather... it's a rather stark landscape. And so maintenance is not full-time. Okay, if you're going to get maintenance up there, it's going to be, okay, it's March, all right, we'll be up there in May. And if it's winter time in the Canaries, at that altitude, it's going to be pretty tough. And Teide is still, although dormant, it's still an active volcano. I say although dormant, it's still active. That doesn't make any sense. But the fact is, Teide is not erupting now. And I think it's classified as dormant, but it could be active at any moment. So on Teide's lower slopes, they actually have these observatories, and a bunch of them on Mount Teide. One of the scopes up there, one of the sets of scopes, is with the SLOOH system, SLOOH. Paul Cox is a guy that runs that, and I've talked to Paul a number of times. And his telescopes are they're half-meter telescopes. But the trouble is, if you want to get exposures, like we're doing 14 25-second exposures, you only get time. You can say, I want a 10-minute exposure or a 5-minute exposure. You can't do like 20 minutes, all right? Or anything. It's going to just be 5 minutes or 10 minutes. But, he's appealing to the masses, and you schedule when you want a photo, and when that photo comes in, it could be after you go to sleep. Then you log in tomorrow, and maybe it'll be there. But if you come in and you schedule, you only get like a certain number of reservations a week. I think it's 5. And so you schedule your object to be taken, and then you will find that your object might be taken that later on or somewhere in the queue, and then you can download it. But you don't download a full resolution shot. You download a JPEG image, and I don't like JPEG images. They're what are called lossy. They lose a lot of their data. This is not working. Okay, we're gonna go a few more on this, and then we'll be done with this. Okay, let's try this. Okay. Tell you one thing, whenever I'm at higher altitude, I I'll get altitude sickness. You know, when I went to 11,000 feet in Denver, or in that area actually on the way, I stayed there for too long, and I started getting weird. You know.
It'll do that.
Yep. It didn't take long to set in, let me tell you.
Yep. We get a ton of tourists here in Colorado Springs.
Mm-hmm.
We're at about 6,200 feet elevation here, and you can drive to the top of Pikes Peak, just west of Colorado Springs, which is 14,115 feet. And a lot of flatlanders come out here, and they don't take time to acclimate, and they get altitude sickness up on top of the peak.
I believe it. Okay, on ping files. Ping files are far less lossy than JPEG files. And the best file to use is a TIFF file format, TIF. So I prefer those. Okay, but if you think about it, TIFF files are much larger. The reason is because there's no compression. Ping files are smaller, therefore there's compression. JPEGs are even smaller, therefore there's more compression. So formats that compress can compress in a way that makes the image look terrible when you zoom in, or allows you to zoom in reasonably well. And PNG files are those files. If you're going to do astronomy, though, then the FITS file is better. Okay, the FITS. And I see Izabela is talking about that right now. Okay, this is our full width half maximum filter. Every single image has come in without fail. The wind speed out there has been about 11 miles an hour or so, 10 to 11 or 12 miles an hour. And so far, it has not affected a single exposure, which is great. Okay, one more exposure to go to 25. And done. Gamma Cygni Nebula. Captured a portion of it. This is a good nebula to do a mosaic with, by the way. We'll do it when there's not a waxing moon of any kind. Okay. So now I'm going to go back to processing with a flat. Okay, there we are. Now we come up here. Go back to our 1 second low light mode. There we go. All right, we'll zoom in a little more. All right, so now I think what we'll do is we're gonna zoom out of this. Okay, a little bit. And now, this is Deneb up here. We did the North American Nebula yesterday. What we didn't do, though, was the Pelican. And it's next to it. So, that's this guy right here. So,
Okay, Pelican.
we're going to go there and check out the Pelican. All right. You'll see the crosshairs for the telescope moving in here. Chris, how you doing? Mindforked is with us. I've known Chris for a couple years now. Great person. Okay, let's zoom in a bit. There we are. All right. Alrighty, so we got these two stars. I see the head of the Pelican is right here. And we'll zoom out to just capture it all. Interview. Okay, now. Thank you, Chris. STLS rocks, she says. All right. Okay.
Django, would you like to have a wrench? I know I've seen people mention his wonderful website. I've never seen it.
Oh yeah, Django's backyard.
If he could, if he had a hammer or a wrench, he could post a link to it.
Yeah, I think that's a fair nomination.
Does anybody second the motion?
Oh, I do. Oh, there we go. There's the head of the pelican.
Nice.
That's very nice, yeah.
That brightest red part is the back of his head.
Yeah.
And the dark thing is his eye, and that's his beak curling down to the lower left.
And it looks like his beak is open a little, maybe. So here he is, a pterodactyl, actually. It looks more like a pterodactyl. This is really nice. This photo will focus on the back of his head.
We talked the other night when we were at the North America, the Cygnus Wall, about the dark nebulosity blocking our view of stars on the other side of it. And we have the same thing going on here. And
yeah, we do.
supposedly there are stars hidden from our view by the dark clouds that are helping illuminate the bright nebula portions.
Yep. Let's move this over. Okay. Now we can zoom in. I love my little gestures. Okay, now we do this. All right. Now we can watch the pelican develop right here. Yeah, it is Chris. Chris says pretty.
I think the pelican has character.
Mm-hmm. Yeah, it does. See, what's neat about this, and the reason why I'm just doing this small area is because I want to, for the first time with this camera, pull out details in the back of this beautiful area here. It's already starting to look a little 3D to me.
Yeah. If you look close, you can see a faint little dark tendril.
This
widening. No, higher up. A dark tendril.
Right here?
About halfway at the back of his head. It's going to the left.
Oh, this one?
That right there.
Oh, yeah, look at that.
Thin little tendril.
All right, let me just get to the histogram for a minute. And let's add some contrast to the background. Oh, yeah, look at that. Wow. This camera has almost twice as many pixels in a slightly smaller region. Our last camera was 4 full moons across by 3 full moons tall. Okay? That means, you know, we're looking at 2 degrees by 1.5 degrees in size of sky. So the entire pelican used to fit in that one. However, now we've got twice as many sensor pixels in a smaller format, meaning that we get more detail per square inch, so to speak. So one thing that eluded us last time was the waviness on the back of this with this kind of detail. We never saw this complex little piece in here. Never saw this. We didn't have access to it. it was invisible to us. But now we have it. Now we see it. It's beautiful. You know, little things like this are incredible. The tendril that Darrell's talking about right here. Okay, look at that little thing. That's really something.
It's got other parts sticking off to the
Oh yeah.
sides of it, up and down.
Like, look at this faint tendril here. Look at that. That's incredible. Just got another exposure came in there. Wow, this is beautiful. And it's weird because I don't remember seeing this much detail in this section here before. But we have detail. Wow.
Penguin reminds me of a cartoon character, and I can't put my finger on it.
Who does?
The penguin.
Penguin?
The pelican. Sorry. There should be a Penguin Nebula too.
I
bet there
I
is.
know who this reminds you of, and it's going to make you even older.
Yeah.
The magpie.
Magpie.
Yeah, little black magpie. The black bird.
Two of them?
No, what was the name of the cartoon? Because that's who this looks like.
Maybe. I thought they were crows and there were two of them.
It might be.
They talked like a lot of jive.
Yeah. Oh, that's even older. I think you better stop talking now, Darrell.
Yeah.
Because before you're done, you're going to be 180 years old. If anyone knows, what's the name of the magpie? That it was a smart aleck magpie. No, not Batman.
Heckle and Jekyll.
Yeah, Heckle and Jekyll. That's right. Thank you, Donald Kunzer.
Those were the crows, I think.
Yeah, but there was, and I think that's what I'm thinking of. But that's what I thought these looked like.
Could be.
Now, Kyle's saying, I see some very faint red stars. Could they be young stellar objects? Maybe. I mean, you can look in here, you can see. Now, any stars that are embedded in this cloud are going to be reddened to some extent. But it's possible that we're seeing a young stellar object in here. There have got to be some YSOs in here. And protostars. You can see, again, that was invisible to us in the last camera. Let me zoom in. Look at this, Darrell. Look at this. Holy cow. I'm going to go to my enhancement and see if I've got that on. I do. Let me turn it off for a minute. Okay. So now when you look in here, we see an incredible number of small stars. These were completely invisible to us with the last camera. Completely. And right here, we have this really interesting location. Look at that little object right there. What is going on in there? I'm thinking there's got to be something going on inside there.
All sorts of dark tendrils show up there now.
Yeah.
The one I mentioned earlier, and
Yeah.
the eye itself of the pelican, and some to its right, some down below it, little zigzags and stuff.
Yeah. There's something
All
going
sorts
on
of
in there.
Tendrils.
There's something going on in here. This is interesting. Oops, sorry. This. It just doesn't end. There's all kinds of really cool stuff. You can see these, as Darrell talks about, these faint areas. I think I can pull those out instantly here by just doing this. Yeah, now they're even more clear. Yes, the rear Rubin camera is 64 gigapixel. Yeah.
And I think they said they'll be able to image the entire sky every 3 nights.
Wow.
And they'll be looking for any changes. And they, I swear I see this at, I forget, some article recently. They'll be able to image the entire night sky every 3 nights. And they intend to watch for short-term changes from night to night, but there's going to be so much data collected that I think they're asking for volunteers or something of the sort to help comb through all the data.
Well, I applied to be their outreach astronomer for the Vera Rubin telescope, and they said that they said basically thanks but no thanks. They already had someone in mind. That's okay.
You probably need a PhD just to sweep the floors there.
No, not necessarily, actually. Look how much detail's in here now.
Yeah.
Let's see if I can redock this anyway to allow us to. I'll leave the telescope out of view for now.
I wonder if that really bright star to the left, is that in a hole or is that just a chance foreground object? Is that driving out the edges around it?
Yeah, it does look like it's driven out a hole, doesn't it?
Yeah.
We'd have to, well...
Sort of like when we look at the rosette.
Why don't we do this? Let's actually do an analysis. Okay, that's 57 Cygni, magnitude 4.80. And let me see if I can get more details. Oh, catalog, bright star catalog, okay. And, oops. We don't need its coordinates.
Why don't I try the old-fashioned way?
Well, you could look up 57 Cygni and see in Simbad or anywhere else and find out its distance, and then find out the distance to the Pelican. We'll save this image with the annotations.
57 Cygni is a close binary system. Constellation Cygnus, about 530 light years from Earth.
Oh, so it's nowhere near the Pelican. It's a foreground object.
Double line spectroscopic binary, orbital period of 2.85 days.
Okay.
Yeah, they don't say anything about the dark whole nebulosity around it, so it probably is, with the distance, a foreground object.
Yeah. Michael Hedrick says, I'm blown away looking at this. And the colors, wow. I agree, Michael. This is really something. Look, if we zoom out to show you the full extent now. Look at that nebula. Wow, let's see if we color correct what we get. Yeah, we get that little extra blue in there that we didn't like. It brought the moon back. We don't want the moon. Moonlight. No moonlight. Out with the moonlight. In with the good light.
Interesting.
There we go. Oh.
That bright star, though, to the left, there's another hole, a dark spot, and it's like it has a star in it, too.
This? Or this?
That one, the hole, that star, 57 Cygni.
Yeah.
And then there's another star to the left. It's like 2 eyes inside the skull.
This?
The whole red cloud there with the 2 dark holes in it.
Oh, of course. Yeah, we got a
See,
dark hole here,
Yeah.
dark hole here.
It's like a raccoon's eyes glowing at you in the dark or something.
Yeah. Donald Kunzer says the head really shows up now. It does. Yep. Let's zoom back into this, the back of the head here. Wow, look at that. I'm just astonished by how much detail we're looking at in here. I'm telling you, this was not visible. Look at these faint wisps here. This was not within reach with that last camera. We're seeing all this detail now. This is looking three-dimensional in the best way possible. Oh, Michael, I know. Michael's like it's like looking at gentle sloping. Just don't have the words for what I'm saying. Yeah, I agree. Keep in mind it's three-dimensional, so it could be coming out at us, it could be swirling around, it could be going away from us, it could be a mix of the two. Yeah. Wow, this is something else. All this dark nebula is sitting over the top of it. So it's in front of the nebula, it's brighter behind it. Wow.
Astrolan 57 Cygni says it's a double-line spectroscopic binary with an orbital period of 2.85 days, eccentricity of 0.15.
You talking about the binary for 57 Cygni?
Yes.
Okay.
Both components are B-type main sequence stars. Stellar classification of B5V.
Mm-hmm.
Anyway.
Very nice. Wow. That's really good.
Curtis Horn is here.
Hey, Curtis. What's up, Curtis? Good to see you.
Looks like a raccoon or a
Oh, this one?
possum or something peeking over the pelican's shoulder.
Up here or over there? Here?
No, the 57 Cygni.
Oh, yeah, right there.
Yeah, what I said looked like a skull.
Oh, yeah, yeah. One eye socket, the other eye socket. An ear, look. I think it looks like one of those small toy horses.
Looks like a rat to me.
Oh. Okay, we saved the image of the annotations. That's good. And we're going to save this just as we see it now. And we'll save exactly the scene. All right. Now what I think...
Michael H. They make such projectors. They're called planetariums. Helps if you have a spherical ceiling. The new ones can do some really amazing things. They're not cheap.
Digistar.
Yeah. The Air Force Academy here in town has a very old school planetarium. Mm-hmm. And it's got down in front of the seating area, tons of little mirrors bouncing lights up onto the roof.
Wow.
Onto the ceiling. Really old school, and it's really dim too.
Wow.
It's not like the new ones.
Alright, what I'm going to do is, I just can't resist. I've got to capture the lower part of the pelican now. That will be our last object for tonight. I think we're good right here. Let's go back to this guy. Let's see where we were. Oops. I forgot to take that down. Okay. Alright, that'll work. 25 seconds again.
Cosmic Ray has a question.
Is there a reference object in this image for color calibration? No. There's no object in here that we could use for good color calibration. No.
I will say the new camera, its color palette or whatever seems to be much truer than the old camera was.
Yeah, I don't disagree.
Very clean blues and reds.
Yeah.
The old camera looked green and orange.
I gotta take this down. I forgot to bring up the life stack. Alright. Let's color correct and do this.
Izabela beat me to it, but
What did she say?
oh, she posted a link to the server.
Oh, okay, great. Thank you, Isabella.
She beat me to it.
We can clear this again.
So will this be like the Pelican's underpants or what?
It'll be like down below, yeah. Let me go and just do one thing else. Make sure we're good here. There's our all sky. And we're up in Cygnus. Here's Deneb. Okay, and this is Cygnus right here. Northern Cross. Moonlight is affecting our all sky right now.
Oh, I guess.
Yeah, I'm seeing that I gotta go in, make a change here. Go to my module manager. Go to nighttime capture. Reset. Okay. And now we can go back to our live view and we should have our data for the next photo. There we go. Okay. So back to our home page. Okay. Just making sure we didn't have any high clouds. The moon, of course, is making it hard to see the Milky Way, so that's par for the course. So we just get that out of the way. And let's go back here. Let's color correct first, and then do this. There we go. This is the lower part of the Pelican right now. And you can see the upper part is here.
Yeah.
So we're now down here.
See the rest of his beak, and maybe that's the pouch hanging off the bottom of his beak.
It is.
You ever see the picture of the dumb pelican trying to eat a capybara?
Maybe.
It almost fits, not quite. And the capybara looks pretty annoyed.
Yeah.
I don't think pelicans are very bright.
Yeah, I saw pelicans that had to be rescued because they did manage to get things in their pouch they couldn't get back out.
Yeah.
Four-legged animals with hoofs that stuck and they threatened to punch through the pelican's pouch.
Imagine a pelican the size of an ostrich.
Oh my gosh.
That would be kind of scary.
Izabela asks if I'm planning to get the All Sky on the web. Yes, I am. I have to wait until I get a dedicated PC for it, though, and then I can get that on the web along with our pan, tilt, and zoom security camera, so we don't have just one view. We'll get a view that can zoom, pan, and tilt, and look around in low light. I mean, that's gonna be very important. Okay.
Excuse me.
And now I'm gonna get some more contrast out of this. Oh, there we go. Look at that. That's beautiful. So these will stitch up nicely together. Could have gone a little lower, but that's okay. And our full width half maximum is going great. We have every image done here. We have 9 of them so far. Excellent. Yes, it does, Ray. He says the All Sky has its own computer. It's a Raspberry Pi. That's right. And in fact, it has a website built in, but the trouble is where it's located, it's connected back to the computer inside the building. And it's from that computer that I need to worry about getting it out to the web. I can't do it from the Raspberry Pi directly. I'm doing power over Ethernet too, so my Ethernet cable going to the Pi is actually creating the it's also the power supply as well. And I've got Wi-Fi disabled on the Pi right now. I mean, I could enable it, but we're in the middle of the desert. The only Wi-Fi would be back to the computer in the building, and that would work. But we have a hard connection, so we don't need it, and the hard connection is far more reliable. I'll work on some of these little puzzles anyway. Lewis, sorry to hear that. He says he had an error on his phone that said the video couldn't be played in the background. Kyle, who is AstroLin, likes to use Cyril a lot to do his processing. The only thing I don't like about Cyril is that they're canned little routines, and you can write your own little routines, of course, but with Photoshop you really have to understand what's going on with the data to do processing well. PixInsight's the same way. It's little canned routines, but they're a little bit more granular. You can actually do much more granular processing, and that I like very much.
You can see his legs now.
Yeah, it's getting better, isn't it?
Yeah, see his 2 legs down under?
Here?
That's one. The other one's over on the right.
Oh, this one?
Yeah. I guess that's his tail between them.
Maybe. And his wings? Right here?
The one on the left is the pouch under his beak. That one.
Yeah. I can see that being the pouch.
That's where the capybara goes.
That's right. Or doesn't. That's where it goes, or not. Temperature out in the building is 31.94 Celsius at the moment. And that will change as the night goes on. And so we find that as the temperature drops, we can get a better delta, because we're actually trying to lower our surface temperature of the sensor down 30 degrees Celsius below the ambient temperature, which is at 31.94. And right now we've been cooling it all night long, and we're only at minus 9.5 Celsius. So that's hopefully will be enough, because we just want to get the ability to take out a lot of the noise from the sensor. So the lower the temperature, the better that works.
Something's flying over.
Yeah, I hear that. Something going into Denver?
Sounded like a helicopter.
No.
Big one, probably flying toward Fort Carson from here.
Astro Lynn Kyle says, what are the theories for stars disappearing? Disappearing stars, interesting. There is a new I guess branch of thinking that maybe what happens is the stars go right from being massive stars to shrinking to black holes without actually, or neutron stars, without actually going supernova. It's odd, it's different, it's not what we expect, but that's a current line of thinking. It's no way proven, but it's just a theory, which is as good as any. Beatriz Villarreal is doing a program to detect missing stars in imagery, and some of the stars she found that vanished disappeared literally within minutes of having just been present. So that was weird.
It's almost like there was no rebound when it collapsed.
Yeah.
Usually the supernova is when, it rebounds off the core and blows up, bada boom.
Yeah, and usually a stream of neutrinos is going to reach us first. But back then, when these stars vanished, there may not have been there certainly wasn't a way to study neutrinos at the time. Cosmic Ray is correct. Stars go on vacation. I'm out of here, dude. They just don't realize they can never come back. Well, Kyle, the black hole would stand out like a sore thumb if we could just get a telescope aimed at it. The closest to witnessing it is when they were looking at a stellar field and literally took another photo of the stellar field a few minutes later, and not just one but 3 stars were missing. Now, how in the world can that happen? It could only happen if something was literally in our atmosphere passing in front of it, and there wasn't anything. At the distance they were, these stars would have had to have had a cloud pass in front of them, moving way faster than the speed of light. Way faster by thousands of times for the cloud to pass in front of the stars And since we know that matter can't travel that fast, it's a perplexing mystery. So even if it was something in our solar system, it would have to travel exceedingly fast to block the light from those stars. And by the way, they never came back. So
GRB is gamma ray burst, Izabela.
yeah.
Astro Leonard asked about Hawking radiation.
Yes. So I just answered. So,
Well,
that's all right.
I mean, Hawking radiation is still hypothetical, isn't it?
Yeah, and I said that the way I answered it was, if it was a black hole, it would stand out like a sore thumb if we looked at it with a radio telescope. The trouble is that 3 stars disappeared in the space of those few minutes, not just one. So that was really the most perplexing part about the whole mystery, is that 3 of them disappeared. Looks like I have like bunny ear or dog ears or something. It's the
Brings
back
up
of my
my old-
chair. Huh?
Brings up my old Star Eaters idea.
Yeah.
Imagine there's things out there that consume entire stars.
Yeah. Yeah.
See any areas here you want to zoom in on?
Yeah. I got one
Looks like
right
some
there.
Tendrils there under the beak,
Yeah.
to the lower right of the beak, or on the pouch, I guess it is.
Oh, look at that. That's really pretty. That's really pretty. There's a lot of detail there. Very nice. Kyle says, what is the Python package for the stars that disappear, or is it neural network based? Back then, they were using film emulsion, I think, at that time. Hello, Cindy Murphy. And the stars vanished on film. So there was no electronic measures whatsoever. Well, Izabela wrote the application in a way that we can actually use the data, Kyle, so we can actually compare every time we took, say, this picture. And we go to this picture every time we took it and compare the previous one to the next one. We have to do that. We actually have to do that like manually right now. But I'm thinking that we could write a little application within Photoshop to take all the images and set them to the right scale when they're not, and then do comparisons. Hello, RJPX. What's happening? Uh-oh. I just yawned. RJP, I'm glad you caught one live. Yeehaw.
Boy, the structure in that, the dark patch just left the center there,
Yeah, look at this.
under the beak.
There's a lot of structure here.
Very straggly, and if it was smoother, I'd call it almost brushed looking, but
Yeah.
it looks almost torn.
Well, remember in the North American Nebula, where the Gulf of Mexico comes in from the wall side, the lower left of it, up and looking up, there's that streaks of cloud, which are just dragged out, and it looks like a brush streak. Look at that. Let's zoom out, see the whole thing. Look at it. It's rare that we have an entire image filled with red. It's very rare.
Very intense down in the lower left-hand corner.
Yeah, I'm gonna save it because we're now at the same number as the last one. All right. Wow, that's beautiful.
See how red that is at the very bottom left?
Yeah. Indeed. And here.
Yep.
All right, so what we're going to do is we're going to do one more object because I lied. I said this was going to be the last one, but that's a lie. I'm doing
Just one more.
just one more. Exactly. So let me get rid of this stack here. Save it. Save it and then save it exactly as seen one more time. And get rid of it. Go to 1. Do our low light mode. There's our low light mode. And as you can see, that's what you'd see in a telescope of moderate size. You wouldn't see any nebulous detail, maybe subtle hints. Okay, so now we're going one more place, which is just gonna be beautiful, and that's gonna be down the other end again. Let's see, we're gonna go here. I know, where's here? We're gonna go to Vulpecula.
Dumbbell?
Don't call me names. Yeah.
The little fox.
Yeah,
Vulpecula.
that's right. And we'll do 6823 another time. Alright. And off we go. Now here you'll see the telescope kind of move toward us a little bit here. There it goes. And we'll see the dumbbell right there. The dumbbell on this camera really looks beautiful. We'll zoom in and check our focus, make sure we're all good. That's great, Kyle. All right, this looks good. All right, so we're gonna pull out of here to there, move us up there, and this doesn't require a lot of exposure. In fact, more is worse. We're gonna just do 20 seconds on this, and that's gonna be high. But we'll give it a shot. So we'll go into our deep sky mode now. Our last image of the lower Pelican will be here. There it is. It's beautiful. Okay, and we're gonna clear this and dock up on this because we don't need to take it off. And there is the dumbbell, the first image of the dumbbell. And that's beautiful. We're gonna color correct now.
Nice.
It is. All right, and now we're gonna move this down in order to initially start to see detail. And that detail includes that little star in there. We can zoom in a little bit already.
Looks very three-dimensional.
It does.
And you have the 10 o'clock and 4 o'clock, looks like jets.
Yeah, right here.
And where they're impacting the outer shell is where the brightest of the red nebulosity is.
Mm-hmm.
10 o'clock and 4
Right
o'clock.
there, yeah.
I think we talked before about we may be seeing precession in action
Yes.
that maybe where those jets used to be, they were on the other side of more like 6 and 12 or something.
Well, they're following this path. So
Yeah.
as this thing moved up and up here, this one moved down. And so it could just be doing this. It could be, if the star could be doing this. And this is probably north or south. And then this is the east and west equatorial region where much of the material is being thrown off from. That's very possible. And then in the middle here, you've got this little object which is sitting right in the middle. And it's this guy right here. That there is the white dwarf. Now the white dwarf is what's left of the original star, because what we're seeing here is what's called a planetary nebula. Is the end state of a star. All right, and this end state is one where the star is about the size of the Earth. That's what's left behind, and this planetary nebula is, I think it's, I forget its distance. It's not thousands of light years away, but it's actually somewhat close. But we can see the white dwarf easily, even though it's only the size of the Earth, and it's still light years away, many light years away. So that's how bright it is.
Give me a second.
Yeah. I'm going to say 1,500 light years. Is that your final answer? Yes. That's pretty.
1,360 light years.
Ooh, that's pretty good. All right.
First planetary nebula discovered by Charles Messier in 1764.
Makes sense too, because if you notice, it's got this beautiful size to it, and it's actually very bright. You know, if we pull this out here, you can see that we have all this other material out here. You'll notice this red doesn't stop here at the edge of the nebula. It continues. See that? Continues.
Yes.
That's really cool. Now we can also do a quick cheater histogram push over here to see what else is in it. And you can see this is sort of a quickie to kind of show us what else is there.
There's a loop of blue just above 9 o'clock on the left.
Yep.
And a closer one just above that outer shell. Looks like an eye.
There's one right here. There's one
another
right
one
here.
Upper right, yes, that one.
Yeah.
And one below it.
I
Just
see.
below the shell on the right side. And the farther one out on the right side too.
I see like tendrils or something sticking off here. Is that real? I gotta find out.
Say it again.
I see tendrils sticking off here.
Oh, I see that.
Hmm. Yeah, there's our white dwarf in there. Well, yeah.
Size of the Earth, and we can still see it from
Yeah.
1,360 light years away.
Mm-hmm.
That's bright.
And remember, stars are only ever just point sources, so the stars that are this bright are actually literally point sources in the sky to us, point sources. But because they're so bright, they saturate our sensor and make them look bigger. And that, I know that gives mystery, and it gives real aesthetic pleasure to the universe to see these beautiful stars like this. But that's not how they really look. It's really a universe full of points of light that are all the same size to us, but are different colors. And that's what we see. Wow, this is beautiful.
I wonder what made the I I call them the eye shape. It's like the corners of the eye to the lower left and upper right. The whole thing is like an eye-shaped ring around the nebula, but very distinctly kind of like a double teardrop shape.
Yeah, this part right here, along with this part right here, this might be like a torus around the star in reality. But we're noticing that there's outer material out here of oxygen that was ejected long before the material from in here, or this stuff was ejected and moving out slowly, and then the oxygen on the outside was ejected and went past it. So you have to. There might have been a process which caused rapid ejection at a higher rate. Not sure. But it's pretty, and if we actually have it do what it wants to, it's gonna blow that right out. Look how bright it makes it.
Yeah. Well, you can see a lot of faint stuff outside the brightly lit part of the nebula. I bet if you ran enough, stacked enough exposures, that would show up easily.
Oh yeah, well we're only doing a 20-second exposure. To see this stuff, we'd have to increase the exposure time. But you're right. All right, let's bring this way back down again. There we go. Alright, so this will be our dumbbell.
Very nice.
It is pretty. That's 24 images. Wow, very nice.
Well, thanks for showing us that.
Yeah, this is really pretty. It's a good shot. All right, that's our just one more. And so what we're going to do now is shut down for the night. And I just want to thank you guys for coming out here tonight to hang out with us. Love having you. Really enjoy having you. If you guys haven't subscribed to us yet, I mean, come on, what are you waiting for? No one's doing this. No one gives you an astronomy lesson with astronomers, okay, and shows you these different objects. We saw Wolf-Rayet stars tonight. We saw stellar nurseries. We saw double stars that are beautiful colors. We see planetary nebulae. And
dark nebula?
Dark nebulae as well, yeah. So it's all out there. Hope you guys enjoyed that. And I am going to go to bed because it's about 2 a.m. Anyway, I hope you guys liked that. We enjoyed it. I got my fix. I'm okay now. I can now go to bed without shaking. All right. So I will see you guys on the other side of the full moon probably, because it'll be a little too bright to. We can still do it, but we get too bright in the center, and it makes it hard. So you guys have a good night, and look forward to seeing you again. And just remember, when you go out, keep looking up. And if you want to check us out and see what we do more, you can go to skytourlive.org and check us out. And if you want to see our pictures on different objects, go to SkyTour Live's shop called SkyTour Shop on Etsy up there up here in the corner. Go to SkyTour Shop. You can get there by going here to go to skytourlive.org, Go to skytourlive.org, and you have access to the Etsy shop from there. You have access to all the beautiful images we took, and you have access to gallery. You have access to a photo service where you can get our pictures on metal, framed under canvas with a glass. You can get images that are on canvas that look gorgeous. I have several. So go for it and enjoy. And we've had some people buying photos and pictures on our darkroom site. I'd love to have you do more. I'd love to see our images get spread around. So you guys have a good night, and we will talk soon. So good night, everybody.
Good night, everybody.
What he said. All right, Darrell. Well, good night to you too.
Good night to you.
All right. See you
Good night,
guys.
Gracie.
Good night, John Boy. See you all later.
Good night, Ma. Good night, Pa.